Hey everyone, welcome to Singularity Computers Client Build 18. I know it's been a long time since I've done a video, a build log, and I know that some of you by now will be starting to give up because I did say that I was at the point in time a couple of months ago where I was going to get back to making a video a week. Well, a lot has happened to me since then. I've had some bad luck, something serious happened in my family. I will talk about this in videos coming up. But the good thing is I have a massive backlog of builds and work to get through, and this is going to be an incredible build. So let's take a look at the components. We have the Asus X99 EWS, 32 gigabytes of Corsair Dominator Platinum, the Intel Core i7-5960X, the Samsung SM951 512 gig M.2 PCIe SSD, an Areca RAID card, 2 EVGA Titan X, and the Corsair AX1500i. For the water cooling components, we have two D5 pumps, Corsair AF120 Quiet Edition fans, 4 Hardware Labs Black Ice SR2 480mm radiators, 2 acrylic Bits Power Upgrade Kit 250s, EK Nickel Plexi CSQ Clean water blocks for the CPU and graphics cards, and also black backplates for the graphics cards. We have Bits Power D5 acrylic mod tops and black sparkle mod kits, and an Aquarius X XT. Now there's still some components on the way, so we'll take a look at the rest of the components during the build log. This build is going into the Caselabs Magnum TH10A. Now I have great memories of building into this case because it was the first Caselabs case I ever built into. When the TH10 was released, I was looking for a case for a personal build, Singularity Beast 2, which you can find an 18-part build log for on my channel. I'll put a link on the screen. And, you know, everything around at that point in time just did not have the radiator capacity that I needed for the, true extreme system that I wanted to build. And I also wanted to have more freedom, options, something that was going to last me through many builds, that was going to be easy to build into and upgrade, because I just wanted to build an extreme system for maximum performance and overclocking. I wasn't so much concerned with modding and aesthetics. I wanted more of a practical case. Just something to have fun with. And that's what you get with Caselabs cases. Something that you can rely on the fact that you're going to get the specifications without restriction, and that you're definitely going to have a lot of fun with. When Caselabs was about to release their small form factor cases, I was unsure if the particular design that they have and the technique was going to work for the smaller cases, but it really does work incredibly well. And you can find a few Caselabs small form factor builds on my channel also into the S3. I'll put a link on the screen. The first components I'm going to be installing into the case are the fans and radiators. So I have here the Corsair AF120 Quiet Edition fans and the Hardware Labs Black Ice SR2 480mm radiators. Now I'm sure that some of you have noticed by now that these are the wrong fans to be installing on radiators. Now the reason I have these fans is for a number of builds that I'm currently doing for case fans. There's also a number of case fans going into this build. Now the AF series fans from Corsair are designed to be case fans. They have lower static pressure and very slightly higher airflow volume. For a fan that you're going to be using on a radiator or a heatsink, you want higher static pressure, driving the airflow, because the air needs to be forced through the fins on the radiator or heatsink. So that is where Corsair's SP static pressure series comes in, and I'm still waiting for those fans to arrive. Now something I'm going to be doing to all of the fans in this build is painting the fan rings, because Corsair fans only come with white, red and blue fan rings, and I think this is a nice little touch. It's something a bit different. Black fan rings should definitely be included though. Now I was very excited about the release of Hardware Labs next gen radiators. They have been out for a while now, but this is the first time I'm using the SR2 in a build. I've used the SR1 many times, and I've been using Hardware Labs radiators for a long time. There's a number of things I really like about these radiators, and one of them is that they're built completely from copper and brass, whereas almost all other radiators have steel in the construction. And I have talked about this previously. I noticed it did create some confusion. This doesn't mean that other radiators have steel in the fluid path, just on the outer panels. The reason I don't like this is because the paint jobs on radiators are notoriously bad, and I find that they almost always rust before you can even get to using them. Usually on the very edges, the corners, they're also a lot heavier. Black ice radiators also have M4 threads, whereas most other radiators have M3 or 632. So M4 threads are stronger, they have better compatibility because you don't have the bolt heads falling through the holes on your case, and the bolts just look a lot better, a lot more sturdy. Black ice radiators also have very good compatibility because they have compact end tanks. Particularly if you look at their GTS, it's the radiator that I use when I have very limited space in a small form factor build because it's one of the most compact radiators out there, but this also goes for all of their radiators. They certainly don't waste any space. They also have very well designed and well thought out fin arrays. I mean, if you're going to go for a thicker radiator like this one, then in the design they can afford to go for a less dense fin array and still maintain performance but have a more silent configuration, whereas with a thinner radiator, to maintain performance, you have a more dense fin array. And you can see that that's what they do with their radiators, particularly their older radiators actually. They've changed the fin arrays with this new generation, but they are still well designed and thought out. So I've installed the radiators, and I'm probably going to change the directions of the inlets and outlets. I haven't yet designed the component order and tubing routing in this build, and I won't do that until most of the components are installed. You know, you can think it all out at the very beginning, but I prefer to wait until I've, seen the components, and then I decide what is going to look best. This is also the first time I'm using the Corsair AX1500i. This power supply is massive at 225 millimeters long. That's to be expected for a 1500 watt power supply which supplies 115 amps on its single 12 volt rail. This is designed to be split up into multiple rails in the Corsair Link software within your operating system. Despite this power supply being designed to run on a 15 amp circuit, it also is 94% efficient, so titanium rated, and it has Corsair's 0 RPM fan mode, so the fan doesn't run until a certain power draw. So it's efficient, it's silent, but incredibly powerful. Mine actually came with a converter cable which converts it down to 10 amps. For me, a removable motherboard tray is often a big selling point because it just makes building a system a lot more fun. It means you can install all of the components into the case with the motherboard and the rest of the components out of the way. So radiators, power supply, everything else. And you can have that side of it completely prepared, and also the motherboard completely prepared. And what I mean by that is CPU installed, memory, all of the water blocks, graphics card blocks. You can tube up the entire motherboard area and then just slide the motherboard tray into the case. And I'll show you exactly what I mean by this with this build. Let's take a brief look at the Asus X99 EWS. This is also the first time I'm using this component in a build. Now this motherboard has some extra features, technologies and specifications that you don't see on many other boards because this is an Asus Workstation board. So we have 10 SATA ports and 2 SATA Express ports. Across the bottom of the motherboard we have a power and reset button, the usual Asus EPU and TPU, LED poster and clear CMOS. You can also see the SATA M.2 port there. Now this motherboard has 2 PLX chips, which means that you can run all 7 of the PCI Express slots in times 16 and then the rest times 8. Or you can run 4 of them in times 16, the grey slots. So I've already installed the Intel Core i7 5960X. This is the first time I'm actually building with the X99 platform, so I'm really looking forward to doing some overclocking and seeing how it performs. The 32GB kit of Corsair Dominator Platinum DDR4 runs at 2400 MHz C14 1.2 volts, so 14, 16, 16, 31. Fairly high timings on DDR4. Another incredible component going into this build is the Samsung SM951 512GB M.2 PCIe SSD. And the performance of this little component is just incredible. I'll have some performance results later in the build log. Currently, I only have the CPU and graphics card water blocks for this system. There's no memory water blocks going into this build, but I have something exciting coming up for the motherboard water blocks, and there's also another water block going into this build. So you'll see this coming up in the build log. But the water blocks I do have for the build are EK Nickel Plexi CSQ Clean, and here I have the EK Supremacy Evo. It's now time for me to install the graphics card water blocks onto the NVIDIA EVGA Titan X. So I have two of these going into the system in SLI, and this is only the second time I've laid hands on the Titan X. I'm really looking forward to seeing how they're going to perform in this system and doing some overclocking to see what kind of extra performance I can get out of this build. Hopefully I'll be able to break some records. We've been talking about this stock cooler for a long time, so I'm not going to say anything about that. It's lasted right through from the GTX 780. But this card has 12 gigabytes of memory. It's amazing to see all of the memory on the back of the PCB. The combination of nickel-plated copper and acrylic is certainly the most popular when it comes to water blocks. And it's obviously because of the ability to see the coolant flowing through the water block. It's something I've chosen many times for my own personal builds, and certainly installed into client builds more than anything else. I'm set up and ready to install the graphics card water blocks. It's been a long time since I've shown a graphics card water block installation, so I'm going to take you through one now and just show you the basics. I'm not going to go into detail because every graphics card water block installation is going to be different depending on the card and the water block. So I'm just going to show you what you really need to know and hopefully dispel some of the nerves that you have, particularly as a beginner when doing it for the first time. I remember that this was really the thing that I was the most nervous about over anything else, because you have an expensive card that you're going to be dismantling, and even the slightest mistake could cause problems or a dead card, and sometimes you're also voiding warranty. But as long as you are really careful, you take your time, you double check everything and follow the instructions, you're not going to have any problems at all. And really most of it's just common sense. So the first thing you need to do is make sure you have everything prepared in front of you that you're going to need, because you don't want to be getting up, going and grabbing things and losing concentration. You want to have everything in reach. So then remove all of the screws from the back side of the PCB. Now for reference coolers, it's always the back side of the PCB, sometimes the back I/O that you need to remove screws from. But sometimes with other unusual coolers, you end up removing screws from both sides. Now once you've removed all of the screws, you grab in one hand the PCB, in the other hand the stock cooler, and start just gently wiggling from side to side, and you'll feel the seal break. When it does, you can pull the two sides apart. Be very careful at this point because there's going to be wires connected for the fan and also possibly lighting, as there is with the Titan X. These can be very difficult to unplug because the connectors are so small you can't get a hold of them, so you're inclined to pull the wires, which you don't want to do because it's just going to pull the wires out and leave the connector behind. So I suggest using a small pair of pliers, either that or just be patient. Now something you need to do is keep all of the thermal pads, so any that remain behind on the PCB, put them on the stock cooler, because you need to keep your stock cooler for warranty purposes. Some manufacturers will provide warranty even if you install a water block. I use ArctiClean to remove thermal interface material, the thermal paste, which will be on the GPU chip itself. It comes with two products, the thermal interface material remover and the surface purifier. Now it's important you use both because you don't want to leave the first product on the surface, because it's going to break down any future TIM you install on the surface, because that's what it does. The second one negates the first one, I find. It removes it, so it means that you get a nice clean surface and you're not breaking down the new thermal paste. Be very careful about where you install your thermal pads. You need to follow the instructions very carefully. Once you've installed all of your thermal pads, you then need to use thermal paste on the GPU chip itself, You can install that however you want to. There's many arguments about that. I have my own way that I know works because I've tested it compared to everything else, other techniques many times. Do one more final check to make sure you've installed the correct thermal pads in the right positions, you know, the right thicknesses, the right amount, all of that. And then you can install the water block. Now, there's a couple of ways you can install the water block. You can lower the PCB down onto the block or the other way around. The benefit of lowering the PCB onto the block is that you can look through the holes and make sure that they line up perfectly. But I just prefer not to do it that way. I find the thermal pads drop off and you can end up with a real mess. I prefer to lower the water block down onto the PCB, and it's easy enough to line up the holes if you do it that way. Now, this was another part of the installation that I remember I was nervous about when I did it for the first time. Getting it lined up. It is important that you have it perfectly aligned before the water block makes contact with the PCB, because once it makes contact, you're not really going to be able to break that seal again without having to redo your thermal paste and reposition a lot of the thermal pads. And you don't want to be, you know, sliding it around trying to line up the holes, because you're going to make a mess of the thermal paste and the thermal pads are going to be misaligned. You're not going to have proper contact, which will lead to overheating and just a bad installation. So if you're more than a mil out of alignment, I suggest you do your thermal paste and thermal pads again. So once it's in position, the first 4 screws you need to install are the ones around the GPU chip itself. They need to be tightened half a turn at a time diagonally until they're tight for even pressure and contact. It pushes, you know, the pressure to the outside of the block so that there's no high spots or ripples in the PCB. Gives you perfect contact. Then you can install the other screws, you know, radially out from the GPU itself. Now, because I'm installing a backplate, there's a little bit more to be done, but usually that would be the end of the installation. Installing a backplate is basically just the same process as installing a water block. You need to make sure, though, that you don't install all of the screws before you install your backplate. Take a look at the backplate where the screw holes are, and obviously leave those ones out. So once you've done the TIM for your backplate, you can position it just like you did your water block and bolt it into position. Now, as I'm tightening all of my screws, I'm looking, you know, down from the side of the water block at the gaps between the water block, the PCB, and the backplate and the PCB. Now, if there is any flex in the PCB, you've done something wrong. The PCB should be perfectly straight, and those gaps should be exactly the same all the way around. I'm now installing the Aquarius X XT. I've always loved the Aquaro. I've used it many times. There were some problems in the early days, you know, with the software always being in beta. It was buggy, there was translation problems, but all of this has been sorted out for a number of years now, and it now works extremely well, and it's very easy to use. So you can see that the XT comes with a remote control. Now, it doesn't actually come with this heatsink. This can be purchased separately. You can also get a water block for the Aquarius X and 5. And cooling this component is important. I remember there was a number of limitations with the Aquarius 5. If it was water cooled, you could actually connect more to it. But with the Aquarius X, these limitations have been overcome, and the amount of components you can now connect to it compared to the Aquarius 5 is truly incredible. You get this cable which connects the Aquarius directly to your motherboard via USB 2. This is extremely important because I don't suggest using the screen and the buttons on the Aquarius or the remote. You need to set up the software and access it through the software. It's very complex, and using the software, you know, the interface makes it very easy to set up. And if you have to do it through the screen, it's just going to take you a very long time. So you get 4 temp sensor cables, which I will be using in this build, and you also get a 3-pin fan cable, which is actually an RPM sensor cable. So let's take a look at the Aquarius 6. This is actually the first time I've used the 6, although I've used the 5 many times. And you can see just how much connectivity there is on the back of this component. It really shows how much of an epic component it is and what it is capable of. So basically, it's for monitoring, control, and management of a water cooling system. So fans, pumps, lighting. And that's not just monitoring temperatures and RPMs, but controlling RPMs and also monitoring flow rates, just the whole lot. And this is seriously the most high-end and the best component out there for doing this, the ultimate in monitoring, control, and management for water cooling systems. And it's not something you really have to have, but in an extreme water-cooled build, particularly one with a lot of fans, it is really going to help. And I'll show you exactly why during this build log. It's an amazing component to have for a build like this. So I'm just installing the heatsink, and there's some thermal interface material that needs to be installed here on some of the components. And it looks like the water block fits onto the back of this heatsink. Now I'm sure this heatsink would be more than enough, particularly for the Aquarius X, which, as I mentioned, I know has been improved. The cooling is not as necessary. But this is a great looking component, this heatsink. It's CNC milled billet, and it has all of the labeling, and the Aquarius X looks a whole lot better with this installed also. It looks a lot cleaner. So wherever the back of it is going to be visible, this is a great option, because once all of the cables are plugged in with nice black connectors and sleeving, you're not going to be able to see much. It's going to look fairly clean. The custom cables have been completed for the core components in this build, so the 24-pin EPS and PCIe cables. You can see there's a lot of cables here, and they're long cables, obviously because of the size of the case, but as usual, they've all been done in MDPC X in black, and it's heat shrinkless sleeving. So these cables are completely custom from the ground up. We haven't taken the stock PSU cables and modified them. I prefer to build them from the ground up. That's it for this part of the build log. Thanks for watching. Please subscribe, like, and favorite if you want to see more.